right, before we start this lesson, I want to show you about how difficult our assignment's going to be today. So what I'd like you to do is to pause the video at this point and take out a single sheet of paper, or if you want to use scratch paper, see if you can solve this equation. When you're done solving, go ahead and start the video and we'll watch the solution to it. All right, hopefully you've had the opportunity to try this problem. So if we look at our equation, we have a bunch of stuff on the left side and hardly anything on the right side, just the 100. So we're going to keep that. We're going to look at combining terms. So simplifying by looking for terms with the variables. And I have three terms with variables, 4, 2, and 1. If I add those together, that would total 7 x's. If we look at our constants, we have a plus 3 and a minus 1, which if I combine those two terms is a positive 2. Now let's just solve the equation. Minus 2, cancels, still have 7x equals 98. Divide by 7, and x equals 14. Good. If you had a 14, and you did a very nice job. Now, if you can put that practice problem away, but not too far away, or we're going to come back to it in a second. I'd like you to turn to your notes section. Because today, we're not going to give the OK problems. We're going to give them to you in a word problem type situation. So we're going to solve word problems using algebra. Now I'm just going to give you the steps to go through right now, and then we're going to actually just show you how to do them with a couple of problems, and we'll have you work out a few on your own and see how well you do. So the first thing we have to do is we have to set up each term using a variable. And it's important that we use the same variable. Now, within there, when you talk about the number of terms, it depends on what they're talking about. If you're talking about 3 people, Billy, John, and Martha, then we need to have 3 different terms using variables. If we're talking about numbers, I'm thinking of 5 numbers, then I need to have 5 different terms. So depending on what the word problem states, you got to read that carefully and figure out how many terms you're going to need. But we're going to set up each one using a variable. Now, at first, that'll be very difficult to do, but this is a helpful way. It's to start, as you read through the problem, you're going to know less about one of those terms than the rest. The one that we know nothing about, that they really don't give us any information about, we're just going to use a variable by itself. Since we don't know it, we'll use an x or a k or a t or an n, whatever variable you'd like. Once we've established that term in the variable, we are going to define the other terms with respect to that variable. For example, if it was 5 more than it, well, we'd take n plus 5. If it was 3 less than it, then we'd take n minus 3. If it was 3 times as much, we'd take 3 times n. So depending on what they tell you about the other terms. Then we're just going to set up that problem and solve for the variable. Excuse me, as you see this first problem, you'll know once we solve, that's not the answer to our problem, it's just the answer to the equation. So let's take a quick look at a problem. I am thinking of 3 random numbers. The first number is 3 more than 4 times the second number. The third number is 1 less than 2 times the second number. And the sum of all 3 numbers is 100. What are the 3 numbers? Now, the first thing we have to do is to set up each one using a variable. So first of all, as you read this, how many different terms or different things are we talking about? So hopefully you got that right from the very first sentence. I'm thinking of 3 numbers. So here's my first, here's my second, here's my third. And well, that's not too bad. But we've got to set up each one of these using a variable. And we're going to start with this one right here. As you read this problem, which one do we not know much about? So let's take a look. The first number is 3 more than 5 times the second. So I know something about the first number. The third number is 1 less than 2 times the second. I know something about the third number. The one I really don't know much about at all is that second. So we're going to start with that term. And so let's just call it n. I don't know much about it. But now that we've defined that term, we can go back to the other ones. So let's go back to this first one. This first number is 3 more than 4 times the second one. Well, how would I write 3 more than 4 times this? Well, 4 times this and 3 more. So we got to, and this goes back to a little bit from chapter 1 when we were writing expressions. Let's go to the third number here. The third number is 1 less than. Oh, 1 less than 2 times the second. 2 times that second. Well, the second was n, so I've been able to define each one in respect to that starting variable. Now, we haven't set up an equation yet. That comes the last problem. Well, what do we know about these numbers? We know that the sum of all of them is 100. So we're going to write them all down and add them together because the word sum means to add. So let's see. My first number, 4n plus 3, plus my second number is just n, plus my third number is 2n minus 1. And we know that these all add up to 100. Now, I don't want to spend time solving this equation. That's why I already gave it to you as that warm-up problem, that practice problem. So assume if you look at the problem you already did on your paper, this is that problem. That's where I got that equation from. I didn't just make it up. It came from a word problem. So when we solved this, we found out n to be 14. Now, that is not the answer to my problem. My question wants to know, what are my 3 numbers? I take that n and I plug it in to all 3 of my numbers. So the first one would be 4 times 14 plus 3. Well, 4 times 14 is 56, plus 3 is 59. And the second number is just n. Well, that's just 14. My third one is 2 times 14, which is 28, minus 1 is 27. Now, we can check this. Is my first number 3 more than 4 times the second? Well, yeah, that's how I got it. Is my third number 1 less than twice that second? Yeah, well, 28 minus, yeah, that works. And I can also check by adding them all up. If I add those up, yeah, they add up to 100. They actually work with what we said. So the hard part here, the hard part in this whole problem is this part right here. This setting up that equation. If you can manage to set up the equation and do this part right here, that's the hardest part. Because it's from there that we actually will set up our equation. So I'd like you to take out a single sheet of paper. And we're going to try one of these together, and I'll have you try a couple more. Tori loves to go to the beach with her parents. Her mom is 3 times her age. Her dad is 5 years older than her mom. Their ages all total 68. How old is each one? So first of all, how many different things do we have in this problem? So hopefully you recognize, well, we have Tori, we have her mom, and we have her dad. So we're going to identify those 3 things. Tori, mom, and dad. Now, as we read that problem, which one of those do you know the absolute least about? So let's reread it. Tori loves to go to the beach with her parents. Her mom is 3 times her age. So we know something about mom. Her dad is 5 years older than her mom, so we know something about that. And we know something about all their ages. So the one we don't know much about is Tori. So let's start with that. Tori is going to be our single variable. Now, what do we know about mom? Mom is 3 times her age. Well, we should know how to write that. Mom is 3 times her age. What do we know about dad? Dad is 5 years older than mom. Not older than Tori, 5 years older than mom. So we have to take whatever mom was and add 5 onto it. So again, we've first of all determined how many terms we're going to need and what they are. Tori, mom, and dad. We used a variable by itself to represent the one we knew the least about. And then we tried to write the other 2 in reference to the first. Now, what do we know about these? All of their ages total 68. So Tori's age plus mom's age plus dad's age all has to equal 68. for a little bit. I lost mom's age there. 68. Total age. Good. Now it's just solving that equation. Let's go like this so we don't. 1, 3, 6, 7x plus 5 equals 68. Let's subtract 5 from both sides. 7x equals 63. Divide by 7, and x equals 9. Now again, that's not the answer to my problem. I've got to take that answer to my equation and put it into all three of the terms that we're looking for. So if I put an x in for Tori, Tori is 9. If I put a 9 in for Mom, she is 27. If I put a 9 in for Dad, 27 plus 5 is 32. You can check because all three of these should add up to 68. And so let's check that. 9 and 7 is 16, plus 2 is 18. Carry the 1, and that does give me 68. I'd like you to try one of these on your own and see how well you can do with, let's see if we can find one. Let's see, 3 numbers. Let's see if we can do one that's a little bit more difficult than that. Now here's one right here. Noah has a jar of coins that he is collecting. There's a total of 72 coins in the jar. That's all we know is how many coins there are total. There are 10 times as many pennies as there are nickels, twice as many dimes as there are nickels, and 3 less quarters than the dimes. How many coins are there of each type? And if you get that and you want to do a bonus question, how much money would that be? But let's really worry about how many there would be of each type. So what I'd like you to do is to pause the video at this point and see if you can set up this problem. And if you're confused, then just wait patiently till we go through it. But see if you can get as much, if nothing else, see if you can define your terms. Okay, hopefully you had a chance to start this. Now there's 4 different types of coins. We've got pennies, we've got nickels, we've got dimes, and we got quarters. Now we're going to look for the one we know nothing about or the least about. So as I read this, there are 10 times as many pennies as there are nickels. So I know something about the pennies. There's 10 times more than the nickels. Okay, let's see what else we know. There's twice as many dimes as there are nickels. So I know something about the dimes. There are 3 less quarters than dimes. I know something about the quarters. The thing we know nothing about is how many nickels there are. So we're going to use a variable for that. Now let's go back and read each one and rewrite what that would be. So I didn't know anything about the nickels. That'll be my x. So let's go to the pennies first, the underlined red part. There are 10 times as many pennies as nickels. 10 times as many. So if there's x nickels, there's 10 times x for my pennies. Let's go to dimes. There are twice as many dimes as there are nickels. Oh, there's twice as many dimes. And the nickels, we said there's x. Now this one we've got to be a little bit more careful of. There's 3 less quarters than dimes. So I got to subtract 3 from the number of dimes. Well, the number of dimes was 2x. And we have to subtract 3. So this is my variable representing each one of my terms. I know together these should all add up to 72. So let's set that up. Here's my pennies, plus here's my nickels, plus here's the dimes, plus here's the quarters. Together, there should be a total of, and I forgot what it was, I'm going to look back up, 72. We simplify and solve. 10, 11, 12, 13, 14, 15x minus 3 equals 72. Let's add 3 to both sides. 15x equals 75. Divide by 15. And x equals 5. Now again, that's not the answer to our problem. That just tells me what x is. So I'm going to put 5 into each one. If I put 5 into this, there are 50 pennies. If I put 5 into this, there are 5 dimes. Nickels, sorry. If I put 5 into this, there are 10 dimes. And if I put 5 into this, 10 minus 3, there are 7 quarters. So how many do we have of each? 50 pennies, 5 nickels, 10 dimes, and 7 quarters. Now, if you did that last question, this would be 50 cents. 5 nickels is 25 cents. 10 dimes is $1. 7 quarters is a $1.75. If you add that all up together, let's see. There's $3.50. Right. The assignment for today will be a worksheet that has 4 problems on. This is tough. It's not easy. You got to set things up. You got to solve. Good luck.